All right. So the first thing we're going to do is we're going to look at situations where we're multiplying a product or we're taking products. So basically, here's how it works. Basically, you have two complex numbers. So remember, a complex number can be represented as R cosine theta plus I sine theta. R cosine theta plus I sine theta. Okay. And basically, you can think about this as, let's say, we'll call this first complex number R1 cosine A sine A. And maybe the second as R2 cosine B plus I sine B. Plus I sine B here. So we got two complex numbers in polar form. Now, if you want to multiply these two numbers together, so if you want to multiply Z1 times Z2, the formula for that is R1 times R2 times cosine of A plus B plus I sine of A plus B. You can write this formula down. You're going to need it to work through these problems. So if you take the two complex numbers in polar form, you take your two complex numbers in polar form and you multiply them together, you multiply the two moduli together first, and you add the arguments. It's really that simple. I mean, really, it's that simple. All right, let's take a look at this problem. First, we're given that Z1 is 2 plus 5i, and Z2 is -1 minus 5i. So first thing we need to do is rewrite Z1 and Z2 in terms of polar. So if remember, with polar, we need two things. One, we need R, and two, we need theta. So the first thing we're going to do is to find R. We find R with R squared is equal to X squared plus Y squared. That's the first thing we're going to do. Or in this case, A squared plus B squared, but you get the idea, right? In this case, for Z1, so for Z1, R squared is equal to 2 squared plus 5 squared, which is going to give you 4 plus 25, and therefore 29. So if R squared equals 29, then R equals square root of 29. Now, the other thing that you need is you need to find your theta. And remember, we know that tangent of theta is equal to y over x. Therefore, theta itself is equal to tan inverse of y over x. So we're going to do that right here. So in this case, we're probably going to need Desmos here. That, or any calculator that you got. All right, so we've got tan inverse of what, 5 over 2, right? And we're going to do that real quick. Let's see. And we want to make sure it's in degrees. So 68 degrees is what I'm getting, basically. Now, remember, this is only my reference angle, so I need to check and make sure that this is the actual angle. Well, let's look at this problem. We got 2, so 1, 2 plus 5, 1, 2, 3, 4, 5 I. So something like this. This is 2 plus 5i. So which quadrant is it in? First, second, third, or fourth? First, and therefore everything's positive. So yes, we have the right theta here. So we can set this problem up and we can say square root 29 cosine 68 I sine 68. So we've turned our first complex number in rectangular form into polar form. I'm gonna give you a minute. I want you to try Z2 on your own. So we did Z1, we just did Z1. I want you to try Z2. Note, by the way, it's in the third quadrant. So be careful about that. So remember, the two things you need to find are your modulus, or R, and you need to find your argument, or theta. Make sure you find your modulus and your argument. And if you need paper, you can ask. If you would rather use one of the whiteboards back there, you can. But this is not a spectator sport, people. You're going to need to actually work through the problems yourself. My goal for the rest of the course is to make the unit short and sweet. This is the end of this unit. I want the units to be short, sweet, to the point, but the only way I can do that is if we're all on top of it. I mean, my goal is to be finished before like 2-3 weeks before the end of the school year, because nobody likes to do work at the end of the school year. So I'm trying to get y'all out of here. All right, let's do it. For Z2. Basically, first we're going to find R. We got R squared is equal to X squared plus Y squared. At this point, you should just be checking your work. -1 squared plus -5 squared. Everybody got that? Then you end up with 1 plus 25, which gives you 26. So basically, R is equal to the square root of 26. We can go ahead and put that there. The second thing we were looking for is theta. So we can say theta is equal to tan inverse of -5 over -1, which actually ends up being +5, but we can just leave it that way. We plug in here, we end up with, let's see, -5 over -1. We get 78.6. I'm going to say 79 degrees. It says nearest degree. So yeah, 79 degrees. 79. Now let me show you how easy Z1 times Z2 is. Note, you're going to take R1 and R2 and multiply them together. Simple. So basically we're going to do 29. Yep. Oh, yes, you are absolutely right. Ooh, yeah, thank you. Good catch. Yeah, so 79 is only the reference angle. You're absolutely right. 79 is only the reference angle. So if we're going to put 79 degrees as a reference angle into the third quadrant, because we're at negative, then we actually need to add 180 to this. So this really should be 259. Great catch. Everybody got that? And yeah, it is so easy to make that mistake. Now we got the square root of 29 times the square root of 26. I don't think that reduces because 29 is prime. So we're just gonna have to do 26 times 29. It's gonna be a pain in the whatever, but still. 754. So we're actually got square root. Says simplest radical form. So yeah, square root of 754, because it's not going to reduce. And then you got, for the inside, for the angles, we just add them together, right? We got A plus B, A plus B. So we got 68 plus 59, 327, I think. If I'm doing my math right. Yeah, 327. So let's check 68 plus 259. Yeah, so you multiply the moduli, add the arguments. So let's see if we're right. We've got, let's see, square root and the 68, square root or SQRT, 26, and 259, and then square root SQRT, 754, 327, that's SQRT. It's a shortcut. Just like for theta, the shortcut is THETA. Yeah, I don't like clicking stuff. Fingers crossed I actually did this correctly. Oh, would you look at that? I mean, I always hold my breath, okay? It's well, you know, a lot of things can happen. All right, everybody cool with that? Yeah. All right, so here's what I want you to do. I want you to try one yourself. Yeah, go ahead and go into your Delta Math. I want you to try one yourself. This is patterns of multiplying complex numbers. It's this stuff right here. If it's zero, if what's zero? That shouldn't change anything. You just still do 0 squared, right? Isn't 0 squared just 0? So you're basically adding 0. When you put it on a fraction, that's gonna mess it up. Right, it depends on where it is. Well, then you have tangent inverse of undefined. What's that? If tangent's undefined, what angle is that at? $270 or 90. Yeah. So if if tangent's undefined, we know that we're at 90 degrees. Yeah. Look, everything we've done up to this point has been building. Don't throw this whole thing of I'm gonna learn it for the test and then I'm gonna throw it away. Oh, that's not gonna serve you well. I'm just saying, everything we've done up to this point has built to this moment. So I tell you what, guys, I plan to work on more today, but I'm gonna call it right there. I'm gonna let y'all just work on these types of problems for the rest of the period. How about that?